In this video, we're going to learn how to integrate your Spring Boot applications with MongoDB. We're going to use Spring Data MongoDB project to be able to connect and persist data to MongoDB. As part of this tutorial, we're going to build a REST API which performs simple CRUD operations, and then we'll go ahead and see how to run database migrations on MongoDB using a library called Mongock. So without any further delay, let's start the video. Hello and welcome to my channel Programming Techie, where I teach you how to build real-world web applications and improve your programming skills. If you're interested in this, subscribe to this channel and hit the bell icon to join us on our quest. So as part of this tutorial, we're going to build a simple expense tracker, and you can find out the complete source code and the written version of this tutorial inside the description section. So before going into more details, we have to first install MongoDB on our machine. So you can download MongoDB by going to the download section of the MongoDB website. We are mainly interested in the community server of MongoDB, and the current version at the time of creating this tutorial is 4.4.3. And if you need help in the installation process, you can refer to the MongoDB documentation, as it's a pretty well documented website. So you can find out the links in the description section also. And if you're on Windows, make sure to run MongoDB as a Windows service. So if you do that, then you need to start, you don't need to start the service every time you are using the database. Okay, so now let's go ahead and first bootstrap our starter project. For that, I'm going to open start.spring.io. And I'm going to provide the project coordinates here as com.programming.techie and the artifact ID as Spring Boot MongoDB tutorial. I'm going to use Maven as my build tool, Java 15, and Spring Boot 2.4.1 version. This is the latest version at the time of creating the tutorial. Coming to the dependencies, first we have to search for the MongoDB dependency, that is the Spring Data MongoDB library. And as we are building a REST API, let's also add Spring Web MVC, and lastly let's add test containers. So this is the library which is helpful to test the MongoDB layer. So this test containers gives us a lightweight throwaway instances of different services like databases, message queues, and so on. The main advantage on using this library is we can run the service inside a Docker container and use the service to test our application. So we will discuss about this more in the further sections. So once this is done, click on generate and the source code will be downloaded to your machine. And now let's open this project inside your favorite IDE. I'm going to use IntelliJ, and this is a very simple Maven project which contains a Spring Boot application class, nothing fancy here. So the first thing we are going to do is to define MongoDB properties inside the application.properties file. In here, you will add the host name, port, database name to this file so that the Spring Boot can connect to MongoDB database. You can also add the properties mainly in two ways. You can either add the host name, port, username, password, and database information one by one using different fields, or you can use the MongoDB URI property from Spring, where you can provide the MongoDB URI. So I'm going to add this information here. The MongoDB URI format is similar to the JDBC URI format. So it starts with MongoDB and then followed by the host name and port, and then we'll provide the schema we are working with. So here I'm going to create I'm going to provide the name as expense tracker, and this schema is not existing right now in the database. So for that we have to first create the schema. To do that, let's open the MongoDB GUI. There are different GUIs out there you can use. The popular one is I guess MongoDB Compass, but I'm going to use Studio 3T. It is a paid software. It doesn't matter which one you use. So in here we have to connect to first the localhost MongoDB and create the schema called expense tracker. And just make sure the schema is created, and once this is done, we can go back to IntelliJ. And in here, if you enabled authentication, you also have to provide username and password. But as we are normally working on the local instance, which is not secured, I'm not going to provide these details. So once the URL is configured, the next step is to create our model classes. So let's create a package called as model inside the Spring Boot project. And inside this package, I'm going to create a class called as expense. And in this class, I'm going to add 4 fields: ID, expense name, expense category, and expense amount. Okay, here the expense category is an enum. So I'm going to quickly create an enum, and inside this, I'm going to create 5 different values: entertainment, groceries, restaurant, utilities, and miscellaneous. And the last field we have inside the expense class is expense amount. which is of type big decimal. Now I'm going to generate getters and setters for this class through IDE. To be able to save this information to MongoDB, we have to define it as a MongoDB document so that Spring can save it inside the database. We can do that by adding the document annotation coming from Spring Data MongoDB project, and we are going to name this document as expense. And inside this document, I'm going to add the ID annotation to the ID field so that Spring understands that this is a unique identifier for the document. Next, we have different fields: expense name, category, and amount. We can either save the document with this field name or we can specify a different field name. So I feel that this expense name is a bit verbose, so I can change that using the field annotation. And to this annotation, I'm going to pass in the name as the value. So by adding this annotation, Spring will save this document with field name as name instead of expense name. I'm going to do the similar thing also for the next two fields. Instead of expense category, I'm going to call the field as category and the expense amount as amount. So normally, to be able to efficiently retrieve a document or also a record inside the table, if you're talking about relational databases, we will define an index so that the document can be retrieved quickly. We can define an index in MongoDB using the indexed annotation. So I'm going to add this annotation to the expense name field, and I'm going to mark this as unique by setting the unique property as true. So this means we cannot store more than one expense with the same name. Okay, so with this, we completed the data modeling. The next step is to create a repository. So I'm going to quickly go ahead and create a package called as repository. And inside this package, I'm going to create an interface called as expense repository. And inside this repository, I'm going to extend this with another interface called as Mongo repository. So this is the interface which is provided out of the box by Spring Data MongoDB project. And by extending this interface, the expense repository will inherit all the basic capabilities to do some database operations, some basic database operations. So if you want to save a document, you need not write any specific logic for that out of the box. So out of the box, we have this save method from the repository, and we just have to pass in the object. Then Spring will automatically save this object for us to the MongoDB database. We will have a look at all these methods shortly, but now let's go ahead and create a REST controller. For that, I'm going to create a package called as controller, and inside this package, I'm going to create a class called as expense controller. And I'm going to annotate this class with REST controller and add the request mapping as /API/expense. Inside the controller, I'm going to create 5 different methods to add expense, update expense, delete expense, find all expenses, and find an expense by name. So to be able to implement these methods, we need to use a service layer. So I'm going to quickly create a package called as service. And inside this package, I'm going to create a class called as expense service. And also here, I'm going to create 5 different methods similar to expense controller. So to implement the CRUD operations, we need access to the repository. For that, I'm going to auto-wire the expense repository interface into the expense service class. And the first method we are going to implement is the add expense method. So this method will be, as part of this method, we'll be passing on the expense from the controller. And inside the method, to save this expense, all I have to do is call the insert method of the expense repository and pass the expense to it. So in this way, Spring will automatically insert the record into the database. So now let's go back to the expense controller class and auto-wire the expense service. And in here, I'm going to call the add expense method of the expense service. And I'm going to return a response entity from this method with status as created. This is a standard REST API convention for the post method. So if you're creating something, we have to return the status as created. So I completely forgot to add the post mapping annotation to the method. So let's go ahead and add it. Okay, now let's go ahead and also implement all the get all expense method so that we can read all the expenses saved to the database back to the service. And inside the get all expenses method of the service, I am going to type expense repository dot find all, and this is going to return all the expenses which are present in the database. And I'm going to simply return it back to the controller. First, I'm going to add the get mapping annotation, and I'm going to call the get all expenses method from the expense service. And then I'm going to encapsulate this result inside a response entity and return it from the controller back to the client. So now let's go ahead and implement the update method. For that, we have to first read the expense from the database and update it. So we can use the find by ID method to read the expense from the database using the ID field. I'm going to add or else throw for the optional, and throw a runtime exception in case an expense is not found with the given ID. When we find the expense, we should be updating it. So I'm going to map the fields and save it back to the database using the save method. Now, if you are persisting an object for the first time, we can use the insert method. And if the object already exists inside the database, and you want to update it, you can use the save method. So I'm going to go back to the controller, and this time this is an update request. So according to the REST conventions, we have to use the put request. So I'm going to add the put mapping annotation for the update expense method, and let's call the update expense method from the service and return a response entity with status as OK. The next method we are going to implement is the getExpenseByName method. Here we are trying to read an expense record with the help of the name field. If you remember, the name field is already indexed. So I'm going to define a new method inside the expense repository called findByName. And this method takes in the name as the method parameter. So instead of relying on Spring's magic to retrieve the record by the name, we can also provide a custom query to Spring Data. In this case, I can provide the raw Mongo query to find an expense by its name. I can do that by using the query annotation, and inside this annotation I'm going to type in the query, but instead of hard coding the value I need, we are going to add a placeholder which is like a question mark and 0, which references the first parameter of the method. If you want to have values to the query, we can just increment this number. If you want to have other values to the query, we can just increment this number based on the parameters, based on the number of parameters of the method. So if you want to read by name and amount, we can pass in the placeholder for name as question mark 0 and amount as question mark 1. For now, we just want to query with the name. So I'm going to reset this and go back to the service. I'm going to call the findByName method from the expense repository and do some exception handling by throwing a runtime exception if the optional return from the repository is empty. Back inside the controller, I am going to add the getMapping annotation to the method, and we will receive the name of the expense as the path variable. So I am going to define the path variable here called name and pass this name to the getExpenseByName method inside the expense service. And now I'm going to return the result back to the client by encapsulating inside the response entity with status as OK. So now let's handle the last remaining method, the delete expense method. Back to the expense service, I'm going to call the deleteById method from the expense repository and pass in the ID we receive from the client. Back to the controller, I'm going to add the annotation and define the path variable as a string variable with name as ID and pass this variable to the delete expense method of the expense service. And as usual, I'm going to return a response entity from the delete method, and this time I'm going to use the status as no content because that is the appropriate return type we have to use for the delete request. So we completed the implementation part. So now I'm going to start the application and go to Postman client to make some REST API requests. So first we are going to test whether we are able to add an expense or not. For that, I'm going to make a post call to the URL localhost 8080/API/expense, and we're going to provide the body of this post request. I'm going to add some random values for the expense name, category, and amount fields. And when you click on the send button, you can see that we are receiving the response as 201 created. And as we are not sending back any response values, we are just seeing the response body as empty. So let's test out the getAllExpenses method now. I'm going to make a get call to localhost 8080/API/expense URL. And now you can see that we have received the expense we have created as part of the post call. So let's continue to test these changes. So let's understand why we need database migrations. If you're working on a Java project, you may have to deploy your applications in multiple environments. And if you made change to the database schema, for example, you added a new field into the document, or maybe you have to remove the field which is not needed inside your data model anymore, or maybe you have to do a mass update of some records inside the collection. So you can either do these changes manually in each environment, or you can automate them with the help of some different tools. If you're coming from a relational database background, you may be aware of the tools like Flyway or Liquibase, which helps us to do these automatic database migration. In the MongoDB world, we have a library called as Mongock, which helps us in running automatic database migrations. So let's go ahead and see how we can install this library into our existing project. So I opened the Mongock website, and here you can see that it is a Java MongoDB tool for tracking, managing, and applying database schema changes across all our environment based on a coding approach. As of now, this is the most up-to-date MongoDB migration library in the market. It supports the latest MongoDB versions and also provides good integration with the Spring framework. So to get started, we have to add some dependencies into our Maven project. For that, we have to import the Mongock BOM project, which is called as a bills of material dependency, which is used to manage the versions of all the dependencies of the Mongock project. This is usually declared inside the dependency management section of the pom.xml file. If you're not aware of what is dependency management and why to use this, you can check out the Maven tutorial in my channel where I explain you in detail about all the concepts of the dependency management. So we have to copy this Mongock bills of material dependency into our pom.xml file. The latest version of this dependency is 4.1.19 at the time of recording this video. If you're watching this video later, just check whether there are any latest versions of this dependency by pressing the Ctrl+ keyboard combination so that IntelliJ will use the latest dependency. So after the bills of material dependency, we need to import the Mongock runner, that is the Mongock Spring version 5 dependency, the Spring Data MongoDB driver from Mongock, and according to the Mongock website, we have to also download the MongoDB driver. But as we are already using the Spring Data MongoDB, the MongoDB Java driver is already downloaded to our project as a transitive dependency. So there is no need to specify this again. Once all these dependencies are configured, just make sure you run the Maven import by clicking on the Maven icon to the top right corner of the screen. And if you check the Maven dependencies, you should see all the Mongock dependency information. So the next step is to enable Mongock in our project. We can do that by using the enable Mongock annotation, which is provided by the Spring Mongock runner. So I'm going to open the Spring Boot application class and add this annotation to the top of the class. After that, we have to tell Mongock where it can find our database migration related code. For that, I'm going to create a new package called as config and create a class called as database changelog. So in a Mongock terminology, a changelog is nothing but Java class which runs the database migrations. Mongock can identify a changelog using the changelog annotation. So I'm going to add this annotation to the class. And now we have to point to Mongock where it can find this changelog class by specifying the property mongock.changelogs-scan package. And the value I'm going to give as com.programmingturkey.mongo.config. So at the time of startup, Mongock will scan this package and identify the changelog class and applies all the necessary database changes inside the class. So one thing to note is that it's not mandatory to have only one changelog class. You can have any number of changelog classes. Mongock will identify the changelog classes and apply them at the time of startup. So now let's go ahead and start writing some changes we want to apply to our database. At the start of the application, I want to add some sample data to our expense collection. And to do that, we can write some methods inside the database changelog class. And these methods are called as change sets. So let's create a method called as cDatabase. And on top of this method, I'm going to add an annotation change set. And this annotation takes in different properties. The first one is order. So we can specify in which order a changelog should execute this change sets. So if we have multiple change sets, we have to execute sequentially. And this will be done based on this order. And the next property is ID, which is unique identifier for each change set. And lastly, we have the author field. Inside the method, I'm going to quickly create some sample data. And to be able to save this data to the database, I need access to the expense repository. So Mongock provides different options to save the data to the database. we can either make use of the MongoDB interface from the MongoDB Java driver, or we can use the Mongock template, which is a custom class from the Mongock library. And lastly, we can also use a specific custom bean. In our case, it can be the expense repository interface from Spring Data. So in this case, we can add the expense repository as a parameter to the changeSet method, and Mongock will automatically inject it. So I'm going to save this data using the insert method of the expense repository. So now let's test our changes. I'm going to start the application. And if you carefully observe the logs, you can see that the changelog is first acquiring a log over the database and then applying the database changes. Once this is finished, it is releasing the log. And you can track how Mongock is managing the changelogs using the Mongock changelog database. If the database migration is completed successfully, Mongock creates this Mongock changelog database and inserts all the changelog entries into it. Once the migration is completed, the changelog entries will be changed to the status executed, and it also stores other information like the change ID, changeSet method name, and the changelog class, etc. So in this way, you can apply MongoDB migrations to your Spring Boot application. So this is the end of this tutorial. I hope you learned something from this, and I will see you in the next video. Until then, happy coding techies.